So yesterday we looked at example 1, and when we wrote the explicit rule, it was very straightforward because we were given 0, 7, or negative 7, which is technically the y-intercept. So then it was very easy to come up with that value. However, if it's not given, there's a little trick to do here, and I want to make sure you know it because you're going to need it for your quiz review. Example 2, so you want to pause the video, copy down the table of values. Wants us to write the explicit rule and the recursive rule. So for the explicit rule, we're going to look for a pattern first. We've got minus 7, minus 7, minus 7, minus 7. So negative 7 is our common difference, and I think you heard me say that at least once last class. However, common difference you'll see more in a little bit. So to write the explicit rule for this one will be very similar to example 1. We are given this 0-step value. Clearly this is arithmetic, so then we know we're doing it in slope-intercept form, where slope is our common difference, aka the rate of change. So our explicit rule will be f of n equals negative 7n plus 8. Plus 8 coming from step 0, this coming from the pattern, or the rate of change. And now if you plug in any step number, you're going to get the value of the number in the sequence. Don't forget to write your boundaries. So from here we're working from 0 to 4. So next to this we can write 0 is less than or equal to n, less than or equal to 4. Alright, the recursive notation, remember, has 3 parts. And so I'm going to write that down here, where we write our first step. Sometimes it's step 0, sometimes it's step 1, it depends. And then we have our recursive rule, where, remember, every time you read this, you're reading the previous step's value. Or what are we doing every time to the previous step? We're subtracting 7. So minus 7. And then we have our bounds, which are 0, less than or equal to n, less than or equal to 4. So everything in purple is recursive notation. I can't solve recursive notation unless I know the previous term, so do know that. So when you're trying to find a really high value term, like 29 or something, you're going to want to use the explicit. Example 3 is going to be the same as well. It's very nice that they gave you step 0. So pause the video and see what you can come up with before I give you the answer. Alright, if this is our initial step, that's going to be our starting value, and here the recursive notation is telling us we're adding 6 every time, so that's our common difference. So we'll write as our explicit, this is the recursive rule, right? We're going to use the recursive rule to write the explicit rule. So the recursive rule tells us they're adding 6 every time to the pattern, so that's easy. 6n, and our starting term is 5. For n values greater than or equal to 1, because we already defined 0. Alright.